I'm going to jail. I'm going to jail if I don't pay taxes on my crypto. And to report the correct amount, I need to create a script in Node.js. This time, this is not a tutorial, this is very serious, so I better get it right. If you don't know me, I'm Julien, and on EatTheBlocks, I teach blockchain development. Here is the problem. When students buy my blockchain courses, some of them pay me with crypto. All of this money contributes to the profit of my company and I need to pay taxes on this. When people pay me with fiat using credit card or PayPal, it's easy. The online platform I use provides a nice report and I can just give this to my accountant. But with crypto payments, I need to create my own report. In the past, I've tried several solutions. First, I try to create reports at the end of each month by manually downloading a transaction list from Etherscan and importing it to my Google Sheets. It was fine when I had only a few transactions a month, but my sales went up and I couldn't keep up anymore. I tried another solution. There is this company called Crypto.io. They help you to do your accounting for crypto. The way it works is that they listen to each transaction related to your address and they automatically label them. For example, it can tell if a transaction, if a product sells, or if it's related to trading, etc. It also connects to several accounting software and sends them transactions automatically. It takes some work to configure it properly, but once you are done, it works perfectly and you don't have much to do. The problem is that it doesn't integrate yet to Binance Smart Chain, and I receive most of my payments on Binance Smart Chain. That's why I decided to solve the problem myself. I've decided to create a script to do automatically my crypto accounting. Every month, my script will automatically create a list of transactions for my address for the current month. For each transaction, it will include the main information given by Etherscan or BSC scan plus the PNL. The PNL is not provided by Etherscan or BSC scan. We will have to calculate it ourselves. What I call the PNL is how much money we earn or spend for each transaction. For example, if we receive 1 Ether and the price of Ether is $2,000 at the moment of the transaction, the PNL is plus $2,000. If we pay 1 Ether to another address and the price of Ether is again $2,000 and the transaction fee is $5, the PNL is minus $2,005. Our script is going to get data from the different blockchain where we receive crypto, and also from CoinGecko to get crypto prices necessary to calculate the PNL for each transaction. And once the script has processed all the data, we will send the result to a Google Sheet. This is going to be a CLI script that we can run directly on our laptop or from a server. For this kind of use case, we could use either Node.js or Python. I personally feel more comfortable with Node.js and there are more blockchain libraries in Node.js compared to Python, so we are going to pick Node.js. Since we are going to use different APIs, we will need to get credentials for access to the blockchain, and CoinGecko, it should be quite straightforward. However, I anticipate that it might be slightly more challenging for the Google Sheet API. Okay, so we have our plan. Next, we are going to start the coding. In this section, our goal is to fetch a list of transactions from the blockchain. The tooling is generally better on Ethereum, so that's why I decided to focus on Ethereum for the V1 of my script. And once we make it work for Ethereum, it will be easy to adapt it for Binance Smart Chain. So I wasn't sure exactly how to fetch a list of transactions for a specific address, so I wanted to explore different approaches. I tried to use Web3 and Infura. If you never heard of Web3, that's a library to interact with any EVM blockchain like Ethereum or Binance Smart Chain. And for Infura, this is an API that allows you to query Ethereum through Web3. If you don't have Infura, you have to run your own Ethereum node, and that's not easy. So here is the idea. I first wondered if there was an API of Web3 to get all the transactions for a specific address. So I checked the documentation and we can find all the API related to addresses. I had a look there, but all I could find was a utility function to work with addresses, like creating addresses, formatting addresses. We can also get the balance of an address, but nothing about a transaction list for a specific address. So I looked for other APIs of Web3 and I thought of listening for transfer events for a specific address. And we can do this with web3.is.subscribe, but it's only valid for transfers of ERC20 tokens. And I also want to be able to listen to Ether transfers. So this approach is not going to work. Another idea would be to listen to new blocks. And for this, we can use web3.is.subscribe. We subscribe to the new block header events. And whenever there is a new block, we can get all the data of this block by using web3.is.getBlock. And this will include a list of transactions. That's really interesting because we can go through this list of transactions and filter the ones where either the sender or the recipient is our address. So there is a new block every 15 seconds on Ethereum, and each block can fit up to 70 transactions. So it looks like our algorithm is feasible. And we would capture both the ERC20 transfers and the Ether transfers. So it looked like it would work, but after thinking about it, I realized it might not be the best idea because we would have to run the script 24/7, and if it ever goes offline once, we could miss some blocks with some relevant transactions inside. So I thought about it and I realized that listening to events from the blockchain doesn't really fit my workflow. What I want to do is to run a script once in a while to produce my accounting report for the previous months. But I don't want to have to maintain a script 24/7 on a server. So with the API of Web3, we are too limited. But what if we use higher level APIs where some backend does the heavy lifting by indexing some data for us and expose convenient endpoints? I did some research and I found that EtherScan, besides being a blockchain explorer for end users, also has an API for developers. And one of these endpoints has exactly what we want. With this endpoint, we can get all the transactions of a specific address for a specific block range. So we're getting closer, but we still have to do some work. In our query, we want to specify a date range, not a block range. But the good news is that block numbers and dates are related. When a miner mines a block, one of the fields of the block is the timestamp at which the block was mined. So we need to find a way to get the block number for a specific timestamp. So I did some Googling and Stack Overflow offered some help. And I found a mention of an NPM package that does exactly what we need. It's called Ethereum Block by Date. It was updated recently and it has a decent number of downloads. So I decided to go with this. And even though it's quite precise, it's not accurate 100%. If you want the block number of a specific timestamp, there is probably no block for this specific timestamp, but you will get the nearest block. So it could be a little bit before or a little bit after. Okay, so now we have a solid plan, so we can start the coding. But first, I needed to create some API keys. So I created a free account on EtherScan and I created my API keys there. And I also did the same on Infura. And after that, I started to work on my script. So this is the code of our project in the GitHub repo of EatTheBlocks. And the script on transactions is in transactions.js. So we're gonna open this file. So first we import Web3, then we're gonna use Axios to do HTTP requests so that we can use the API of EtherScan. Then we have the library Ethereum block by date that I just told you before. Then I wrap all my code in a function. And so first we're gonna instantiate a Web3 object and we pass it the URL of Infura. So for this, I just showed you before that you need to create an account on Infura and create a project there. And then we instantiate an ETH data object and pass it Web3. And after, we're gonna use this object by calling the getDate function. So we pass it the start date of our range, the end date, and I will show you after where does this come from. This is basically in our configuration. And after we get the number for the start block and for the end block, and we are ready to query EtherScan. And so after to query EtherScan, we are going to prepare our query. So first we're going to prepare the query for the list of transactions with a token transfer. Here the important part is action equal token transaction, and we pass our address. So this is also in the configuration of the script, the start block, the end block, and the API key. And we're going to prepare another query for the list of transactions that are not token transfer. So in particular, most of them are going to be Ether transfer, and we pass the same info as before, the address, start block, etc. So now we are ready to send our query to EtherScan, and for that we use the Axios library. We do a GET request, we put the prefix for the API of EtherScan, and so we put to query here, and then we have our two responses, so the list of token transaction and the list for other transactions. And after, so we're gonna extract the actual token transactions from the object returned by Axios, because there are a lot of stuff that we don't care about. The payload is actually in .data.result. And for the other transactions containing mostly Ether transaction, we are going to filter out all the transactions that were sent to us but that have failed. And so here you know that if the field is_error is equal to 0, that means this is a valid transaction. Otherwise it has failed. But for the list of token transaction, by default, it only sends a valid transaction. So we don't need to do this filtering. And after, we're going to process our two lists of transactions. So first, the list of token transactions. So here, for each transaction, we are going to overwrite some field and add new one. So for timestamp, this is a string, so we're going to turn it into a JavaScript number. So for value, so that's the value of token transfer, we're going to do the same thing. And for token transfer, you have to take into consideration the token decimal. So for most token, we have 18 decimal. That means, for example, if there is a transaction where you transfer one DAI, here for transaction value, it's not going to be 1, but it's going to be 10 power 18. So you're going to need to divide this by 10 power 18. So that's what we do here. And after, so the gas used, so that's number of gas that was used to pay transaction fee. So we transform this into a number, same for gas price. And then we add two new fields. So this is to be consistent with the other list of transaction. So the name of the asset and the address. And for the other transactions, so we're going to do something similar. So for the value this time, for the Ether transfer, the number of decimals is always 18. And for the asset name, so here we're not only going to get Ether transfer, we're also going to get some interaction with smart contracts that are not token transfer. So if the transaction value is 0, so here there was no asset transferred, or at least not an asset that we're going to process in our script. So we just put NA, otherwise if transaction value is not 0, this is Ether. And for the asset address, we only care about Ether. And for the asset address, so in this case, this is not applicable. And so we concatenate these two arrays and we return them from our function. And below, if you are curious, I put an example of the data that is returned by EtherScan for the other transactions and the token transaction. Okay, so we have our list of transactions. Next, we need to fetch prices of Ether. If we want to fetch crypto prices, we don't want to use the API of any specific exchange. We want to calculate the average of the prices of the biggest crypto exchanges so that we can get the true market price. And for this, I thought of using the API of CoinGecko. There is no need for any API key, their documentation is good, and on top of it, they have a Node.js library. I checked out their documentation and I found exactly the endpoint that we need. It gives us the historical price for a specific coin and a specific date. So now we have a plan. Let's see how we can code this. Okay, so this is our project. So we will go to prices.js. That's where we fetch the prices. So first, I import moment. This is a library to work with time. Then I import the client of CoinGecko. So this is a Node.js library to easily interact with the API of CoinGecko. Then here I instantiate the CoinGecko client. And here you can see we don't need to give it any API key. So that's very easy. Then I define a function to pause our code momentarily. So you're going to see how it's going to be useful after. Then this is a function to tell if a transaction is an expense or not. So for that, we just test that the from field of the transaction is our address. And we need to make sure to transform these addresses to lowercase because there are two formats for Ethereum addresses. So otherwise, this comparison is going to fail. Then for the main part of the code, so we wrap everything in init function and we pass to this function the list of transactions that we got previously from EtherScan. And we define an array of transaction. So we're going to copy paste some field from the original array and we're going to add the price of Ether. So here we are going to loop through the array of transactions. And first we are going to convert the timestamp field of each transaction into a moment object. And we're going to format this with this format. And we do this in order to use the CoinGecko library. So here, this is the client of the CoinGecko library, and we're going to hit the endpoint that gives us the historical price of a coin. So this is coin ID history. So the ID of our coin for Ether, this is Ethereum, and we also pass the date that we got thanks to the moment library. And then we scroll down, and so here we are going to extract the price of Ether in US dollar, and we transform this to a JavaScript object with a parseInt. Then we calculate the sign of the transaction. So if this is an expense, this is -1, otherwise +1. And we're going to use this for the cash flows. So here we define the cash flow of our asset in dollars. So if the asset is Ether, so the way we calculate the asset, this is the sign time the transaction value time is price. Otherwise, if this is a stable coin transfer, there is no need to multiply by is price. So this is easier. And after, we also calculate the cash flow for the transaction fee. So if this is an expense, this is going to be a negative cash flow. And so we're going to multiply the gas used by the gas price by the Ether price. And we divide everything by 10 power 18 because the gas price is given in terms of the elementary unit of Ether, but its price is not. So we need to do an adjustment. And if this transaction is not an expense, so we receive some money in this case, we don't pay any transaction fee. So the cash flow here is 0. And after, we can calculate the P&L for the transaction. So we just add the cash flow of the asset to the cash flow of the transaction fee. And after, we are going to add a new entry in our transaction with prices array. So here we push a new entry as an array, and that's because after, when we're going to add this to Google Sheet actually expect an array for each row. So here we put some data, some field that we need, and very importantly, we put the cash flow that we calculated before with the P&L. And after, before we go to the next transaction, we are going to wait for 200 milliseconds because the API of CoinGecko has a rate limiting in place. So maximum, you can have up to 10 calls per second. So we could, in theory, only sleep for 100 milliseconds. But you know what? I want to be cautious. So here I put some security margin. And at the end, once we finish the for loop, then we just return the array transaction with prices. And so at this point, we have all the data that we need. And the next step is to save this data in our Google Sheet. So at that point, we have our list of transactions with the prices of Ether. So that's good, but unless we can present this information in a readable way and store it, that's not very useful. So that's why we still need to put this data in a spreadsheet. And for this, we will use Google Sheets. Once we have this list of transactions, we can just sum the P&L of all transactions to compute the total P&L of the months. And with this, we can do our crypto accounting every month. When I first worked on this part, first I thought it'd be easy compared to what we've done before. Well, not exactly, because this time we need to face Google. Google has many different APIs, and even to do something simple, you usually have to spend a lot of time reading their documentation and try a few things before it works. So I checked out the documentation and I saw an example for writing to a Google Sheet using Node.js. In their example, they assume that you already have created a connection to the API. So I had to keep reading their documentation to understand how we can create this connection at the first place. And that's when I saw that they use OAuth2. Ouch. So OAuth2 is a protocol for delegated authentication. So when an app wants to integrate with some services that you use, like Google Drive, it will use the OAuth2 protocol. That is what is used under the hood when you see Windows that say, do you want to allow such app to access your Google Drive, for example. But in my case, the app I'm building is only for my personal use. I don't intend to create a service for other people. So I really don't want to spend time understanding the authentication flow. So I just want to keep it simple. So I wonder if it wasn't possible to just use a good old API key. And it is possible to connect with an API key. So at that time I was happy. I thought that it's going to simplify everything. So I coded my integration with Google Sheets by using an API key. And it didn't work. The error message was that I wasn't authenticated. What? How comes? Am I not using an API key? I did some Googling and I understand that with Google APIs, you can use an API key if you only intend to read data from public resources. The API key authenticates your app, but not you as a user. If you want to modify private resources, you do need to use OAuth2. Damn. So I really didn't want to use OS2, but I had no choice. So I roll up my sleeve, I check out the example of OS2, and I discovered that they use all style callback all over the place. That means you don't understand clearly the flow of execution. You call one function that calls another one, etc. And that's really ugly. And I didn't want to do that, but I still have to use the OS2. And then I realized that it was possible to do something called promisification in JavaScript. So with promisification, you can turn some old code with callback to some modern JavaScript function where you can use async await notation. And so for this, you need to wrap the old functions with a promise. Okay, so at that point, we have a good plan. So we are going to dive into the code and I will show you my solution. Okay, so the code for updating the Google Sheet is inside google.js. So let's check this out. So first, we import these two libraries. So this one to read the file system, and this one is to get some input from the terminal. So this is going to be used for authentication for the Google API. And after we import the Node.js library to use the Google APIs. And after, so we define the scope. So this is required for the authentication. We're basically telling Google that we want to authenticate user and have this permission. So this is going to be enough to update a spreadsheet. And after, in the init function, so we see the main execution flow. So first we get the credentials. So the credentials identify our app, and then we are going to ask the users to authorize our app, and we're going to get a client. And with this client, we're going to be able to update the spreadsheet, and we're going to update the spreadsheet in the update function. It's going to receive the client and the list of transactions that we created previously. Okay, so now let's see all these functions, how they work. So first, get credentials. So here we are going to read a local file where we have our credentials. So when you create a project in the developer dashboard of Google, you need to create an OAuth2 configuration. And after, you're going to download a JSON file and store it on your laptop. So it's this file that we are reading. This only authentifies the app. It doesn't authentify a user. Also here, you note that I wrapped everything with a promise. So if you check out the official example of Google, you will only see this. So before I mentioned the concept of promisification in JavaScript. So here it's how I do the promisification with this function. Okay, so after we have the authorize function that allows to authenticate a user, so it's going to receive the credential that we pass from our local file, and with this credential we're going to be able to create an OS2 client object. We're going to try to read a local file where we store our local token. So local token, this is used if you already authenticated your user before. It's going to store an authentication token on a file locally. But if this is the first time you use the script, this file is not going to exist. So in this case, we need to create this token. So for that, we call the function getNewToken. And so first, we are going to generate an authentication URL. And after, we are going to print a question on the terminal. So enter that page here. So we're going to have the URL that we need to copy paste in your browser. So you go to your browser, you do a few clicks, you authorize the app, and then it's going to give you a token. So you copy paste this token to your terminal, and then we are going to save this token to our OS2 client object, and we're also going to write this token on a local file. And after, we resolve the promise, the OS2 client, and after, the execution flow is going to continue with the update function. So here, this is the OS2 client, and here for the value, so this is going to be the list of transactions. And so first, we create a Sheets object. So this allows us to work specifically with the API of Google Sheets. Then we create the different fields for the header of our spreadsheet. We store this in an array, and we add this at the top of the values array. And so here we create the resource object. So this is for updating our Google Sheet. Then we also define a range in which we are going to paste our data. So we need to identify the sheet. So in a Google spreadsheet, you could have several sheets, sheet 1, sheet 2, etc. And after, we specify also the range with these notations. So for this, you need to specify the top left corner and the bottom right corner. So we have 12 columns total. And for the number of rows, so this is the length of the values array. And after, we are going to do the update here to specify the spreadsheet ID, the range, the resource, so that's where we have our actual data. Value input option. So there are two options, but with this option here, Google Sheet is going to auto format our value. So especially string and numbers going to have a different formatting after we resolve the promise. Okay, so now our code is complete. Next, I'm going to show you a demo. Okay, so for the demonstration, we are going to the terminal. So this is where I have the code of my project. And first, I'm going to show you the configuration file. So I'm not going to show you the real value, but in env.example, you can see a template. So here I've created an API key for Infura, for Etherscan. For Binance Smart Chain, they have a public API. Then you'll need an API key for BSC scan. Then Google token pass, it can be any value you want. That's where the script is going to store the authentication token from the Google API. Then Google credential, this is the same. You can put this anywhere on your system. Then Google spreadsheet ID. So this is the ID of your spreadsheet. So you can see this in the URL of your spreadsheet. Then here you need to put your Ethereum address or Binance Smart Chain address. And then a start date and end date. And it needs to be a day string with the format of ISO 8601. So here you have an example of how it looks like. Okay, and I'm also going to show you index.js. So that's the main script that ties everything together. So here we import the three files I showed you before: transaction, prices, and google.js. First, we show to the user what's happening. Then we fetch the transactions from Etherscan. Then we get the Ether prices from CoinGecko. And finally, we update this info in our Google spreadsheet. Okay. So now we are going to run our script. So node index.js. So it starts the crypto accounting for this address. We can see the date here. So this is for the month of June. It's fetching transaction. Now it's fetching the prices from CoinGecko. And after, we are going to do the update for Google Sheet. Okay, and here it tells you authorize this app by visiting this URL. So here we copy paste this URL and we paste it in our browser. And so you're gonna see a page like this. So here I select the account with which I want to authenticate. So here Google tells me it hasn't verified this app yet. So this is normal. This is still in development. So we can continue. And here it tells me that this app is asking me this permission for my Google Sheets. So I will accept, and by clicking on continue. So here I need to tick this, click continue. Okay, so here it gives you a code, basically your token. So you copy this, you go back to the terminal, you paste this code, press enter. It's going to store the token or the local file, and then it does the update. And here it tells me that it has added 30 transactions. So after, I go to my spreadsheet, and now we have all of our transactions. And here we can see the P&L for each transaction. And at the very bottom, what we can do is we can do the sum of all these P&L, and we have the P&L for the months. And okay, so here this is the P&L for the month. So that's what I need to declare to the tax authorities, and I will pay my crypto taxes based on that. When I first started to code this project, I was a bit stressed because the stakes are high. I absolutely couldn't make any mistake, or otherwise I will report the wrong amount to the tax authorities and I will be fine. But as I was making progress through the project, I started to have fun, especially because I was manipulating real data, integrating different APIs, and there was a real use case. And that's really what I love about blockchain. We manipulate real financial assets with real consequences. This is more stressful compared to just changing some color codes, but it's also what makes blockchain so interesting as a developer. And if you want to go to the next level in your blockchain career, you need to create an advanced project. And one of the best ideas is to create a decentralized exchange. Before you start building your own DEX, you need to understand how it works. And for this, you can watch this video. I will see you there.